the previous chapter, we were talking about equations in one variable and linear inequalities, okay, in one variable. Now, we're going to leave that and we're going to start discussing equations again and linear inequalities again, but in two variables, okay? So that's basically what's going to happen in this chapter. In this module, we're going to talk about linear equations in two variables, and then after we know about those, we're going to discuss inequalities. Okay, but before we talk about this, we need to talk about something else. Remember, when we were dealing with linear equations in one variable, the solution were numbers. So you need to know how to deal with numbers. And as you know, we have the number line, and then you can graph a number very easily. You have 0, then to the left of 0, you have the negative guys, and to the right of 0, you have the positive guys, right? But now, we're going to be dealing with two variables, meaning that one line is not enough. Okay, so one dimension is not enough. We're going to need two dimensions. In other words, we're going to work in the plane. So instead of numbers, we're going to deal with points now. Okay, so let's talk a little bit about that so that we can set the language straight. So these are called rectangular coordinates. And I expect that most of you are already familiar with this. So let's, this should be some sort of review. So rectangular coordinates. Sometimes they are also called Cartesian coordinates, okay? And basically the idea is that we want to make sure that in this screen right here, that this is a plane, okay? Every dot, every point that I put in this screen, we want to be able to give it a name, okay? So we want to be able to differentiate that dot from this one, from this one, from this one, okay? To be able to do that, right now, there's really no difference unless we put a coordinate system on this, okay? So basically what we do is we fix a point that we call the origin, okay? And then we're going to draw a pair of vertical lines. So let me do that. Okay, so let's fix this point somewhere here. This point is fixed, and then I'm going to draw a pair of lines, one vertical and one horizontal, which, as you know, this is called the x-axis, and the vertical one is called the y-axis. So the x-axis is the horizontal one, and the vertical one is the y-axis. The moment that we do this, then you can think of each of these lines as being a number line, okay? So you have here 1, 2, 3, and so on. -1, -2, -3, etc. The same thing on the y direction. When you go up, it's positive. When you go down, it's negative. The moment that we do this, then every point now on the screen is going to have a name, okay? So, for example, if I want to talk about this point right here, let's see, let me go here. If I want to talk about this point, let's call it P, then we're going to talk about them as follows. This is going to be given by a pair of numbers. I'm going to call them x, y. Okay, there's a big lag. The boss is writing now. Okay, and then how do we talk about this point? So what makes this point different from something else? Well, we're going to go down vertically onto the x-axis, and we're going to read off whatever number we have in here. Okay, and that's the number that we put in the first entry of the pair, and then we go vertically towards, in a perpendicular way, towards the y-axis. That's called projecting the point, and we read off whatever number we have in there. Okay, so if we do that, for example, here we're going to see that we get 3, and then over here we see that we get 1, 2, 3, 4. So we're going to call this point the point 3, 4. Do you understand this? That's the name of that point. And now, this way, if I just give you a pair of numbers, a value for x and a value for y, there is a unique position of that number in this screen. Do you understand this? You move on the x direction, whatever the x is, and then you move on the y direction, whatever the y is, and then you get your point. Okay? So, for example, the point, let's say the point Q, so plot, let's call it Q, and let's say that Q is a point -1, -2. So what is that point? Well, this point right here is 0, 0, right? Because this is 0 for x and this is 0 for y. And then this is telling me to go -1 on the x-axis, so 1 unit to the left, and then -2 on the y-axis, so that's 2 units down. So that guy is down. Okay? So it is -1, it is -2, and this is where the point Q is. So that's a point -1, -2. So understand that points, the convention is that they are written x comma y. Okay, so the first number is always the x value, and the second number is always the y value. Okay. Any questions on this? Is that clear? All right. Now some more terminology. The moment that we draw this x and y axis, this screen now is split into 4 pieces. Okay. So this piece over here, which is when both x and y are positive. This one, which is x is negative and y is positive. And then down here, both x and y are negative, and here x is positive and y is negative. They have names, okay? So this is called quadrant 1. So it's called quadrant 1. Typically, we just denote this by the letter Q and then the Roman numeral 1. So this one is quadrant 2. This one we call quadrant 3, and this one is quadrant 4. Okay? So sometimes we say, for example, I would say that P is a point in quadrant 1, Q is a point in quadrant 3. Okay, so we like to speak about the position of the point. Where is it? And we mean the quadrant. Okay? So, for example, there are a pair of inequalities that define each of these quadrants. We already know inequalities, so we can write this down. Quadrant 1 is defined by what? Is x positive and y is positive. Okay? You combine these two together, then you get points that are on quadrant 1, because both x and y have to be positive. Who can tell me the defining inequalities for quadrant 2?
X is negative and y is positive.
X is negative and y is positive. Okay? How about quadrant 3?
They're both negative.
X is negative, y is negative. And how about quadrant 4?
X is negative and y is positive.
Okay.
Or the switch? No, X.
The other way around, right? So x is positive and y is negative. Yes? So any questions on rectangular coordinates? Okay, good. So let me just say here, point is given by a pair of numbers denoted x comma y, and this is called the coordinate. And the first value, so the first number represents the x value. So I'm putting x in quotation mark because it doesn't have to be x, okay? Typically we use x and y, but it could be, I don't know, t over here and then b over there. Let's say that you're talking about velocity, okay? So the movement of a particle, and you are interested in the velocity of this particle over time. Then here you have t for time, and over there you have v for velocity, okay? So the name of the variable doesn't really matter too much. So call a coordinate, and the first number represents the x value, and the second represents the y value. Okay, so right now when we start talking about equations in two variables, the solutions to the equations, they're not going to be numbers anymore, they're going to be points. In other words, they're going to be pair of numbers. Okay, you're going to just give me one number, you need to give me now two numbers. The value for x, the value for y. Okay, so we'll be talking about points now. All right, any questions on this? No? Okay, so then let's do a couple of examples just to get more familiar with this. I'm going to give you some points and I want you to plot them. So, example, plot the points. Let's see, let's say point A is going to be negative 2,1. Point B, let's say negative 3, negative 1. Point C, 4, negative 4. And negative 4, 4. And then finally, point E is the one with the fraction, -4, 3/2. All right, so let's plot these points, but before we plot them, I want you to tell me where they are, okay? When I say where they are, I want you to tell me the quadrant that they would like, okay? All right, so let's prepare. So let's see, the highest y that we're gonna have is 4. Should not have enough space for that. And then for x, it's also 4. So it should be enough. Okay, so x and y. So let's see, point A. Can anybody tell me in what quadrant is it?
2.
Quadrant 2. Okay, very good. And so how do we plot point A? I go 2 left and then 1 up. So it will be 1, 2, and then 1 up. So here is -2, here is +1. So right here is point A. Questions? All right, the next one. What quadrant is it?
3.
Quadrant 3. How do I plot this guy?
Left. 3 to the left and 1 left.
3 left, 1 down. Good. So down is -3 and then -1. So over here. That's B. Yes? All right. C. What quadrant is it?
4.
Quadrant 4. And how do I plot this?
4 to the right and 4 down.
4 to the right and 4 down. So 1, 2, 3, 4, and then 1, 2, 3, 4. -4, +4. So right here. That's our point C. Good. How about D? What is it?
1 and 2.
Quadrant 2. And then we go 4 left. That's to -4 and then 4 up. 2, 3, 4. Okay, that's D. And then finally E. Where is it? Quadrant 2 as well. And then that means we need to go 4 units left and then 3/2 up. So remember, 3/2 is now is very helpful to write this as a mixed number. How can we write 3/2 as a mixed number?
1 over 1/2.
1 and 1/2, right? This is 1.5. So that means you go 1 unit and then the next one is split in 2. And then you just take half of it. So it's going to be right here. It's 3/2. So it's going to be right in the middle. So that's point E. All right, questions about floating points? You okay with this? All right, let me ask you one more question. Then let's say, how about point F? Let's make it 3, 0. Where is this point?
It's just 1 line.
What line?
The X line.
This is on the x-axis. Yes, does everyone understand this? Why is it on the x-axis?
Y is 0.
Because y is 0. So what does every point on the x-axis have in common? It's going to be important for us later. What does every point on the x-axis have in common?
Yes, sir. Y is 0.
The y is 0. Okay? So when you want to know what's the point on the x-axis, you just need to make sure that the y is 0. Okay? And then you just have to worry about what x is. Okay? When we are analyzing equations, those points that are solutions to the equation and belong to the x-axis, they have a name. They are called the x-intercepts of the equation. Okay? They are important. And to find them, you just need to say, okay, y has to be 0. And then you figure out the x. Okay? All right, so F, so that's a 3 right here. So it's point F. And then similarly, for example, about point H, let's make it 0, -2. What is this?
So Y intercept. So it's on the Y.
So this is on the y-axis, right? So what does every point on the y-axis have in common?
X is equal to 0.
the x value is 0 because you don't move horizontal, right? You only move either up or down depending on the point. So in this case, it's down here, -2. Once again, when we talk about equations, we're going to be interested in this type of points as well. This is called a y-intercept, okay? Because it will be a point on the y-axis. And to find it, you just make x equals 0, and then solve for 1, okay? We're going to be doing that like in the next section. All right, any questions about plotting points and seeing the location of the points? No? So, by the way, notice that these guys, F and H, they are not in any quadrants, okay? So we say, where is F on the x-axis? Where is H on the y-axis, okay? All right, so now that we know, rectangular coordinates and so on, let's go ahead and let's talk about equations. So the ones I want to study are linear equations in 2 variables. So let me write down the definition. So a linear equation in 2 variables. Again, I'm going to use x and y, but it doesn't have to be x and y. It can be whatever variable you want. Okay? A linear equation in 2 variables is an equation, of course, that can be written in the following form. That can be written in the form ax plus by equals c, where here a, b, c are real numbers. The only variables here really are x and y, okay? Are real numbers. And then the condition is that both a and b cannot be 0 at the same time, okay? Because if both these guys are 0, then there's no x, there's no y. So what are we talking about, okay? So one of them has to be non-zero. But the other one of them could be 0, that's fine, but the other one cannot. So where a, b, and c are real numbers, and a and b cannot both be 0. Okay, so that's what a linear equation in 2 variables is, and then we are interested in finding solutions to this equation. Okay, so we're gonna see what that is and so on. This has a name. It's called the standard form, because there will be other forms that we're gonna write down for a linear equation in 2 variables. This one in particular, we call it standard form. So we call this standard form. Okay. All right. So who can tell me what would be a solution to this equation? How would you define a solution to an equation like this? So what do you think we're looking for? See, A, B, C are real numbers. Those are numbers that are given to you. When you see the equation, A, B, and C are numbers. So what do you think we're looking for?
X and Y.
So what? What do you think? Looking at your experience from equations in 1 variable. Did any x do the job when you were solving an equation?
We're looking for X and Y. When you add them, they're equal.
So when you plug them in, you get a true statement. Okay? So to solve an equation like this means that you need to give me an x, you need to give me a y. So when I put it here, I get a true statement. I get the left is equal to the right hand side. Do you understand this? That's what we're looking for. For equations, it's always the same thing. To solve an equation means you want to know what the variables are. Okay? What should the variable be equal to so that you actually get a true statement? So, let's see, let me give you an example. So example of these equations would be, let's say 2x plus 5y equals 9. Another example, 3/2 times x plus 1. So notice that this technically is not in the standard form, but you can write it in that form. For example, I could move the 3/2 x to the left, and I could rewrite this as -3/2 x plus y equals to 1. And now this has a form that we have in the definition. Here a will be -3/2, b is going to be +1, that's the coefficient of the y, and c is equal to 1. Okay? So these are examples of linear equations in 2 variables, and our job is to solve these guys. So note the solution to a linear equation two variables is now a point, okay? It's a point. So the value for x and the value for y, that's all a point is. The value for y. So when plugged in, when plugged into the equation, it makes it a true statement. Okay, that's what a solution is, a point. When I say a point now, you know I'm talking about a pair of numbers, okay, x and y. Okay, so let's go ahead. I'm gonna give you some equations. Like we're gonna have these two, and then I think with these two is enough. Then I want you to find. I'm gonna give you some points, 2 points. You're gonna tell me whether they are solutions or not. Then I want you to find 2 more solutions for each of these equations. Okay. So example. So determine if the given points are solutions. So determine if the given points are solutions, and then find 2 more. Find 2 more solutions. And then let's see. So the first equation that we have above, 2x plus 5y equals 9. Let's look at the point A. It's going to be 2, 1, and then the point B is going to be negative 1/2, 2. Okay, so let's do this together. Okay, so job here, the question says all we need to do is determine whether this point is a solution or not. So what is it that we need to do? Just plug it in, right? So, okay, if you want to know whether it's a solution or not, then when you see an x, you put 2. When you see a y, you put 1, okay? So I strongly encourage you, when you are replacing, when you're plugging into an equation, just replace the variable by a parenthesis and then put inside the parenthesis what you're supposed to plug in. That way, you avoid making mistakes with signs and so on. And remember, our job is to see if the left equals the right hand side. All right, let's see. So if we evaluate this, what do we get? 2 times 2, that's 4. 5 times 1, that's 5. So is 4 plus 5 equals to 9? Yes. It is. So we're good. Okay. So this guy is a solution to the equation. Do you understand this? All right. So let's see. Let's do B. So again, I'm going to plug in this point, and then let's see what we get. So here we put negative 1/2, and here we put 2. Okay, so what's 2 times negative 1/2? So negative 1, remember. So the 2's cancel, so you get negative 1. So we get negative 1 plus 10. Does this equal 9?
Yes.
Negative 1 plus 10 is equal to 9. So we're good. So that means this guy is also a solution. Of course, if we get something here that doesn't make sense, then we will say it's not a solution. Okay? We'll see in the other example. All right, so for example, right here, you can see that linear equations in 2 variables, they may have more than 1 solution. As you can see right now, we just found 2. The point is that there are actually infinitely many all the time, okay? So let's actually come up with 2 more. How do you think we can do this? How would you find 2 more solutions? Any ideas? How can you find 2 solutions? So remember, what is it that we need to do? We need to figure out an x and a y that makes this work, right? Well, you can pick an x and then figure out what's a y that works. You can pick your favorite x, put it here. What do you get? You're gonna get a linear equation in 1 variable now, right? So you can find the y that works for that x. And then you pick another x, and then you find the y that works for that other x, and you get your second solution. Does that make sense? Similarly, you can pick a y, and then figure out the x that works. Okay? So So you're free to pick whichever you want. So let's practice that. So 2 more solutions. So the idea here is pick a value for one of the variables and then solve for the other one. For example, since we need 2 solutions and the 2 points that we're going to find, I'm going to do one by picking an x and solving for y, and then the other one I'm going to pick a y and solve for x. Okay? So you see both ways. In this case, when it's given to you in this form, it doesn't really matter. But for example, the other example we're going to do, it would be more convenient to just pick values for x, as you will see. But in this case, it doesn't matter. All right, so let's see. For the first one, I don't know. Give me what value would you pick for x? 4. Okay, so let x be equal to 4. Then all we need to do is figure out what's the y that we need. Okay? Okay, so let's do it. So I'm going to put 4. I don't have a y, so I'm going to keep it like that. So all I did was, whatever x was, I put a 4, and now my job is to figure out what y has to be so that this makes sense. Do you understand this? Okay, let's do it. This is now a linear equation in one variable. We already know how to deal with this. So we have 8 plus 5y equals 9. You know the drill now. Move the 8 to the other side. So you get 1, right? 9 minus 8. And then, what do I do? Divide by 5. So we get y equals 1 over 5. So if you make x equal 4, the only y that makes sense to be able to have a solution has to be 1 over 5. Do you understand this? So we got one solution. So 4, 1 over 5 is another solution. Are you okay with this? Okay. Now, for example, when you are doing this kind of stuff, I would advise you pick nice and small numbers so that you make your life easier. Okay. 4 is fine, but for example, you could pick I don't know, 0, -1. You know, small numbers, so that because later what we want to do is we're gonna graph all of these things. If you start picking big numbers, you're gonna need to have a big graph. Also, when I see this, if I'm about to graph something like this, I wouldn't want to have stuff like this. Okay, so we'll talk about how we can avoid having fractions when it comes to graphing. Sometimes we cannot avoid, but sometimes we can. Okay, so because this is fine, but for graphical purposes, then you have to deal with this 1 over 5 business. Okay, which is a tiny little thing, 0.2, right? And so, all right. So that's one solution. Then let's find another one. So let's see. This time, let's pick something for y. So what do we do?
I said 3.
3? Okay, so let y equals 3. Okay, then remember our job now is we want to know what is x. Okay, all right, so we have 2x plus 5 times 3 equals to 9. And then let's figure out what x has to be. So let's see, who can tell me what x needs to be? Do it. What is it?
Oh, -3.
-3. Okay, very good. So let's see. We get 2x plus 15 is equal to 9. Move the 15 to the other side. So we get 9 minus 15. That is -6, right? And then divide by 2. So we have x is equal to -3. Good. So what's the other solution that we found?
-3, 3.
Good. So -3, 3 is another solution. So remember, the first number is x, the second number is y. A common mistake is that sometimes you guys tend to switch this thing. Okay, you switch it. You tell me 3, -3, that's a different story. Okay, -3, 3, that's a solution. Okay, questions? Do you understand this? Now, when you're doing the homework, you have to see, sometimes it may ask you to write x equals something, y equals something, and then you just do that. Or it will ask you to give the solution as a point, okay? If it says as a point, this is what you need to write. But, if you're writing for someone, you can either do this or say, okay, x is equal to this and y is equal to this. That's also fine. All right, so let's see. Let me give you the other one. So how about y equals 3/2 x plus 1, and then verify 2,4, and then verify 4,1. Let's see, try this out. So determine whether, which one is, whether there are solutions or not, and also find two more solutions, okay? Take it then. Okay, Matthew Bueres, Matthew Cabrera,
Here.
Alexa Caso, Nicolas Cruz,
Here.
Natalie de la Fuente, Adrián de Velasco, Cristian Galvis, Ashley Garcia, Brian Garcia, Juan Girón, Cliff Guadano, Antoine Heredia, Andy Hernandez, Ashley Hernandez, Jorge Jimenez, Angelina Lacombi, Ladies Lopez, Brian Martinez, Daniel McEwan, Oscar Medina, Kylie Murcia, Nicole Oviedo, Victoria Padrón, Darío Pesic, Tomás Puente, Chris Puig, Giselle Pupo, Sebastián Rodríguez, Michael Sánchez, Catherine Silvestro, Melissa Solorzano, Sergio Sordo, Brianna Toruno, Marcel Villafane, Gabriel Villalón, Sebastián Villegas, Andrés Saldívar, Andrés. All right, what do you think about the first one? Is it a solution?
Yes.
Yes, okay, good. So let's see, what do? We plug in, right? So notice that now y is on the left, okay? So you need to put 4 in there. So the statement is, the question is 4 equal to 3/2 times 2 plus 1? That's what we need to verify, okay? So notice that the y is on this side and this is the x. Okay, so check this. Again, here the 2's cancel out, so you end up with the statement that 4 is equal to 3 plus 1, and indeed 4 is equal to 4. So we're good. Okay, so it's a solution. How about the next one? Is it a solution? What do you get?
1 equals 6 plus 1.
So it's not a solution. So this one is not a solution. Good. So again, we do the same thing. Just plug in and see what happens. So we have 1, that's our y, is equal to, with a question mark because we don't know, 3/2 times 4 plus 1. Now remember, when you multiply fractions, this is 4 over 1. You do top with top and bottom with bottom. And stuff in the top can be cancelled with stuff in the bottom. Okay? So this 2, we can cancel it with the 4, leaving you a 2, because 4 divided by 2. And then you do 3 times 2. Okay? Which is 6. So we are left with this statement. That 1 is equal to 6 plus 1. So we get 1 on the left and 7 on the right. Well, this is definitely not true. Right? So it's not good. So it's not a solution. Do you understand this? Okay, good. So now we want to come up with 2 more solutions. So let's see. Notice something. Notice that when we plug in these points, it was very nice because the 2 in the denominator of the 3/2, it canceled in both cases. Okay? Why did that happen? Because the x values were chosen to be even in this exercise. You see, here you have a 2, here you have 4. So whenever you have a situation like this, and you want to look for solutions, notice that here it's very convenient to just pick x, values for x, and then you solve for y. Because if you pick values for x, you just plug in and you evaluate. You don't need to solve for anything. Y is already solved for. Okay? If you pick a value for y, that's fine, but then you need to do work. You have to move the 1 over and deal with the 3/2 and all that business. Do you understand this? So it's easier when it's like this to just pick values for x, and then you will get your y by just evaluating. Now, be smart about it. So pick smart values. What do I mean by smart values? Pick numbers that will cancel the 2. So pick multiples of 2. You can pick, for example, 1 or 3 if you want, but then you need to, you put a 1 here, you're going to have 3/2 plus 1. You need to deal with that. If you put a 3 here, you're going to have 9 over 2 plus 1. You have to deal with that. Do you understand what I'm saying? So you want to pick values that will cancel this guy. So if you have another denominator here like a 7, then I'll pick multiples of 7. 0, 7, 14, 21, -7, -14. You know, nice numbers that will cancel whatever denominator I have down here. Does that make sense? Because you're going to be dealing with equations like this a lot, and you will need to plot those solutions. So you want to end up with nice points like this, okay, to plot. You don't want to end up with fractions. All right, so let's look for 2 more solutions. Let's see, what should we pick for x? So 2 more solutions. So what do you want to pick? 6. Okay. So the first one, we can let x be equal to 6. So then in this case, let me put the equation here. So remember, our job now is to figure out y, but that's fine. All you have to do is plug in. Okay. So 3/2 times 6. What is this? 2 cancel with the 6, giving you a 3, and then 3 times 3 is 9. So again, 9 plus 1, which is 10. So that means that we have the point 6, 10 is a solution. Do you understand this? All right. So let's look for another solution. Again, stick to small numbers. For example, if you wanted to graph this, this is fine, but you need to go all the way to 10 on the y-axis to plot this point, okay? Make your life easy. 0 is the easiest thing to plug in. So pick 0, okay? 0 is a very nice thing to plug in. So let x be equal to 0, okay? So who can tell me what will be y in this case? What is it? Just 1. Remember, if you let x be equal to 0, anything times 0 is just gone, right? Basically, picking x equals 0, you are getting rid of this term right here. This is gone. Then you get y equals 1. Okay? You don't have to deal with anything. So make your life easy. All right. So in this case, we get the y is equal to 3/2 times 0 plus 1. That's just 0 plus 1, which is 1. Okay? So we have another solution here, which is the point 0, 1. How do we call this point? What is this guy?
Y-intercept.
This is the y-intercept for this equation, okay? Because there's a point on the y-axis. And notice that the y-intercept, what you really care about is the y value, right? Because you already know x is 0. And notice that the y-intercept is already right here, right? So this is going to have a form later. This is called the slope intercept form of the equation. Okay, we will address that in the following sections. Okay, any questions? So what you need to know is right now, what's a linear equation in two variables, and then how to identify solutions. Either if I give it to you, then you need to test, or find solutions yourself. And as you can see, we can go here over and over, we can generate as many solutions as we want, right? Just pick whatever, just keep picking values for x, and then you get your y's, and you can get infinitely many solutions, okay? So when we say solve an equation like this, we want to know all solutions. We don't just want to see a couple of solutions. Now, there are infinitely many, so we cannot just write them down. So what do you think we do? Remember, when you solve linear equations in one variable, you would write the solutions down, right? But in this case, what do? Yeah, you have infinitely many. So what we do is we draw a picture, okay? So we try to draw a picture that will show all solutions in there. Just like what you did for linear inequalities that we're drawing a picture, well, we're gonna do the same thing here, okay? Because you cannot just give me a list, because there are infinitely many, okay? So let's do that. So I guess the remark here is remark linear equations in two variables have infinitely many solutions. Infinitely many solutions, and so what we do is we draw a picture of it. Okay. So let's see. Let's go ahead and let's graph. Let's do one example, and then hopefully we're gonna learn something from it. Okay. All right. So example. Graph the solution set of the equation. Let's do something nice. Let's do 2x minus 3. Okay. So here we have an equation. Okay, it's a linear equation, two variables. Let's graph a solution set. In other words, we want to produce a picture that will show all possible solutions for this equation. Okay. All right. So what's a graph? I guess I haven't defined to you what's a graph of an equation, but basically a graph of an equation is going to be in two variables. It's going to be a two-dimensional picture, a graph on the xy plane, showing some points. And basically the meaning is that any point that is a solution to the equation has to be in your graph, and any point in your graph, if you plug it here, it will be a solution. Okay, that's what we're looking for. So typically what we do is we do a table of values, unless we know better. Okay, so right now, because we don't know better, we're going to do a table of values, but pretty soon you will not be doing tables of values anymore. Okay, but if you don't know anything about the equation, just do a table of values. In other words, we're going to find some solutions. We're going to start graphing those solutions, and we're going to see if they exhibit some sort of pattern. Okay, is there any special shape that they have? Okay. So because here we already have y equals something, I will just pick values for x, and then we're going to be figuring out the y's. Okay. All right. So let's see. I'm going to pick 0 because that's a very nice small value, and then let's see. I'm going to pick 1. I'm going to pick -1. Now notice that if I keep on picking more negative numbers, what's going to happen is I'm going to be getting bigger negative y's, because you're going to have 2 times something negative minus 3. So for example, if I pick -2, I'm going to have a -7 for y, and so on. It's going to get too big. So I'm going to pick positive now, because you will be subtracting, so you're going to get smaller guys. So I'm going to pick 2, and then 3. I think 5 points should probably already illustrate what's happening here. All right, let's see, but let's complete the table first. So this means when x is 0, you need to tell me what is y. When x is 1, tell me what is y, and so on. Okay? Let's see, who can tell me the first one? When x is 0, what is y? -3. Does everybody understand this?
Yeah.
All you need to do is plug in and evaluate. Okay? All right, when x is 1, what do we get? -1. You have 2 minus 3, right? Okay, when x is -1, what do we get? So we get -2 minus 3. What is that?
Oh, -5.
-5. When x is 2, what do we get?
1,
+1. When x is 3,
3,
we get +3. All right, so I'm going to go ahead and I'm going to plot these points, and then hopefully we will see some sort of pattern happen. Are there any questions how we obtain these values? So for example, here we found 5 solutions of that equation, okay? This is the point 0, -3, 1, -1, and so on, okay? All right, so let's plot this. Let's see what we get. You know, for this, that's why I'm using like the graphing paper thing here, because if you want to really see how it looks like, you need to have an exact scale. Otherwise, your graph would be off, and so on. But you know, when you're doing it on paper, it doesn't. As long as you show me the points, that's all I will be looking for. Anyways, let's see. So x and y. Let's put our points. So the first one is 0, -3. So that is down here. So 1, 2, 3. So here's -3, and we have that point. Number is on the y-axis. Okay. The next one is 1, -1. So that's 1, -1. So our point is right here. Then the other one is -1, -5. Okay, so that's -1 here, and then 4 or 5 down here. That's the other point. Then we have 2, 1. So that's 2, 1. This is 2 and this is 1. And then we have 3, 3. So 2, 3. Okay, so these are our 5 points. And you could start looking for more points if you want. But let's see, let's take a look at it. Do you notice something special about the arrangement of these points? It looks like they are all they will all lie on a straight line. Yes? On a line. Every line is straight, right? So it looks like they will all lie on a line. So let's see if that's true. I mean, if you have a perfect scale, you should be able to put your ruler and then see. And when I say perfect scale, I mean, you know, your spaces on the x and the spaces on the y, they are all the same, and so on and so forth, okay? If you're off, then the point will be off. But as you can see here, you know, I'm using these little squares to help me out. Indeed, they are all on the same line. So the question now is it true then that every point on the equation, every solution of the equation will be on this line that I'm about to draw? And also the other way around, is it true that any point on the line will be a solution to the equation, okay? That's actually a theorem. So let me first write down the line. So draw the line. And you know, actually the statement is that indeed, every time that you have a linear equation, that's why we also call it a linear equation. The graph of that is going to be a line, okay? So every point on this line is a solution, and also any solution that you come up with is going to be on this line. Let's actually test it. Let's solve the equation graphically. For example, this is supposed to be on point. Notice that this line keeps going up and down, okay? Let's see if we can find another point on the line right now, just by looking at it. So looking at this, you see this guy right here? This is something that we can easily read. I mean, there are many points, but you know, if I pick this one, I don't know what's the x, what's the x, what's the y. You could pick this one or this one, okay? Because we can read, because they are nice on the intersection. So let's actually figure out those. For example, there are 2 that we can come up with. So let's write them down and let's see if they indeed solve the equation, okay? Because right now we are only sure about those 5 that we computed ourselves. Now the line is the one telling us that these are also solutions. So let's see the blue one. What are the coordinates of that? What's the x value?
3. No, 4.
So down here, so it should be 4. And what's the y value?
5.
5. So This is 4,5. Let's see, is it true? So to check whether this is a solution or not, what do we need to do? We put x equal 4 and see y must be 5, right? So if you put 4 for x, what do we get? Get 8. 8 minus 3 is 5. So that's good. Let's test the next one. So what are the coordinates of the next one?
X is 5.
So x is 5. And what is y?
7.
7. All right, let's see. If you put 5, what do we get? We get 10. 10 minus 3 is 7. So at least now, hopefully, you kind of have more trust on what I'm telling you here, okay? In fact, this is a theorem. If you just keep on writing solutions, they will all be on this line, okay? Or maybe way up there or down there. And the other way around. Pick a point on this line, you will solve that equation, okay? Now, at some point, we need to stop. So we just draw this, but it's understood that this keeps going up and down, okay? All right. Are there any questions on this? All right, now let me ask you, and this is, like I said, this will always be the case. Every time that you want to solve a linear equation in two variables, meaning every time that you want to graph it, the graph will always be a line, okay? Now, it doesn't have to be this line. It depends what the line is, right? It could be a line like this or a line like that, okay? So now, the question is, how do we draw this line? As you just saw, for example, here we plotted 5 points, and that was enough to draw the line. Is this really what we need? Do we really need to find 5 points? So my question to you is, how many points do you need if you want to draw a line?
2.
Okay, good. 2 points. So 1 point is not enough, right? If I put a point here, you know, there are many lines going through that point. So 1 point is not enough to draw a line. At the moment that you put 2 points, that's it. There is only one line going through those 2 points. Do you understand this? So when you're given an equation and you need to draw a solution set, and you need to draw the line that corresponds to that equation, all you need to do is come up with 2 solutions, 2 points. We typically look for 3. Why? Because we can use the third one as a testing point, just to make sure that indeed we are drawing the correct line, okay? But the third point is really just to test to make sure that it's also on the line, okay? But you need to have a perfect scale and so on for that to really work nicely. But the minimum that you need is 2 points. 1 point is not good, and then 2 points is all you need, all right? So for now on, that's what you're gonna do. You should look for 3, because the third one is really just to test. Is that clear? All right, so let me right here, theorem. The solution set of a linear equation in 2 variables is a line. And then to draw such a line, all we need is to find 2 solutions. So that is 2 points. And then draw the line through them. Okay. And I will say here, remark, typically a third point is found just to check. Okay, in other words, to make sure that you indeed, that you're drawing the correct line, because if you put 2 points, but if one of the points is wrong, you don't know if you have the correct line. But if you put another point, unless that other one is also wrong, but hopefully you make a mistake once, but you don't make it twice. If that's the case, then you will see that your points are not aligned, so something is wrong. Okay, when you're plotting your points, you get a point here, one over here, and then another one over here. Well, let me go. You already know something's off here. Okay, this cannot happen. Okay, they have to be nicely aligned. So, all right. So let's do some examples. let's see, graph the equation. And let's do y equals 2x plus 1. And do y equals negative 3/2 x minus 2. And then let's put it in standard form as well. So 2x plus 5y equals 9, the one that we're looking at earlier. And also let's take a look at this one. Y equals 3x. Okay, so here we have 4 equations. Our job is to graph them. Okay, so let's graph this equation. Let's graph the solution set. Again, you first need to realize that these are all linear equations. Do you understand this? They are linear equations. So how are the graph of this? How do they look like? What did we just say? These are lines, right? So to draw these lines, what do you need? To draw that, what do you need?
At least 2 points.
2 points. So that's what we need to do, right? Find 2 solutions. You already know how to find solutions. Plot them and draw your line. Okay? So this is not supposed to be hard. This is very straightforward. Okay? You just need to find solutions. Now, nobody's gonna tell you what x to pick. That's your job. My advice: pick small x's so that you can get nice points. Okay? All right. So let's see, x and y. So I'm gonna pick x equals 0. Okay, I'm gonna pick x equals 1, and then I'm gonna pick -1 just for testing purposes. But we don't really need that third point. Okay, but that's just for testing purposes. So let's see. When x is 0, what is y? 1. When x is 1, 3. When x is -1, what do we get? -1. So, okay, be careful when you plug in, right? So if you put -1 there, you're gonna have -2 plus 1. That's -1. Okay. All right. So now let's plot these guys and be good to go. Okay, x and y. So let's see. My first point is 0,1. Where is this point? It's on the y-axis, right? So right here, 0,1. Then 1,3. Where is it? Remember, there are names for each of the places. Quadrant 1. So that's 1,3. So 2, 3. So at this point, you could already draw the line if you want, but I'm going to put my third point just, to make sure that indeed I got the 2 correct points. So -1, -1. That will be right here. And then hopefully you agree that they do appear to be aligned. And if you put your ruler, then nothing funny will happen. Okay. Any questions? Did you understand this? Yeah. Okay. So when you have something like this, we say that the line is going up because it goes. Remember we read graph from left to right. Okay. When you look at this from left to right, it does appear that the line is going up. Yes. It goes from quadrant 2 from quadrant 3 to quadrant 1. Okay. All right. So we're gonna come back to that later. How about number 2? Let's do that one. Once again, we're gonna choose our little values, right? So what value should we pick for x? Anything we want? So okay, you can pick whatever you want, but if you want to make your life easier, what should you be picking here?
0.
Yes, but you have to pick at least 2 more or 1 more at least. So
0, 1.
you should pick even numbers.
4.
I mean, you can pick 1 if you want, but then that's not gonna cancel the 2,
so
right?
cancel the 2, that's right.
You're gonna have to deal with the -3/2.
So 0, 2.
Okay, so pick even numbers: 0, 2, -2, 4, -4. pick nice numbers, okay? Otherwise, you're gonna have a hard time trying to graph and so on, and you could make mistakes finding the y, okay? So make your life easy. All right, so I'm gonna pick 0, then instead of 1, I'm gonna pick 2, and then I'm gonna pick -2 for checking purposes. Okay, let's see, when we plug in 0, what do we get for y? -2, okay, good. What happens when we plug in 2? -5. Does everybody see that? If you put 2 for x, that's just gonna cancel the 2 in the bottom, right? And you get -3 minus 2. Is that clear? All right, so you get -5. And if you put -2, what do we get?
5.
So,
4.
let's see, if we put -2, what do we get? Look at it. What happens? The 2's cancel, right? But because we put a -2, what happens to the negative in front of the 3/2? It becomes positive. So you get 3, because the 2's cancel. You get 3 minus 2. What's 3 minus 2? 1. Right? Do I need to write that down? No?
No, yes, write it down.
Yes, write it down? Okay. So for the last one, you have y is equal to -3/2 times -2 minus 2, right? So the 2's cancel here. Remember, this is over 1, okay? Anything on top cancel with anything in the bottom. So now negative times negative is positive. So you end up with 3 minus 2, which is 1. Yes?
I don't get why you have to put the x and the y there. Can't you just graph it like with the -2 and then go down and then go to the left?
Yeah, but you're using something that we haven't talked about. What are you using? You're using the slope, right? So you're using, that's what we're gonna do in the next section. This is like the basic stuff. This is what you can do in any equation.
Oh, okay.
For example, if I put a square here, you can play this game as well. It's just that the shape is not gonna be like a line. It'll be a different shape. But you can just find points and then you plug it in. That's what you do, the elementary way of doing it. Now, then what you do is you study those type of equations because you don't wanna be doing tables every single time, okay? And then we're gonna see in the next section that there's something here called the slope, and the slope actually tells you the shape of the line and how to draw that line. So you will only need 1 point, and with the slope, you can do what your classmates say, okay? We're gonna do it, but that's coming later, okay? All right, any questions? All right, good. So this was 1. Okay, so let's draw this. X, that's y. So let's see, 0, -2, so that will be down here. And 2, -5, so I need to go down more. So that's 2 and 3, 4, 5. It's right here. And then -2, 1. Again, it's always nice to do 3 points because that will allow you to check and make sure that everything is what's supposed to be. Notice that this time, we don't get a line that's going up, okay? We are actually getting a line that's going down. All right, and again, this will be seen in the next section. Basically, what determines where your line is going to go up or down is if you have the equation written in this form. Remember, we call this slope-intercept form. This little number here is the one that tells you what's going to happen to this line. That number is called the slope, okay? Now that your classmate brought that up. And the sign of this number tells you this behavior. If the slope is positive, in this case positive 2, your line goes up. If it's negative, you're going to have a line like this that goes down. Okay? So when you use the slope for drawing, sometimes you need to go up and right, but sometimes you need to go down and right. Like here, down and right. Okay? You have to be very careful. But we're going to do that in the next section. All right. Any questions? Okay, good. So let's see. Why don't you try number 3 on your own? And tell me where the line is going up or down. Okay, so let's see. For number 4, is it going up or down?
Up.
Going up. Okay, good. So can you give me 2 points?
0, 0, 1,
So tell me the x and the y.
0, 0,
0, 0. Good.
1, and 3.
1, 3. Let's see one more.
-1.
Okay, so let's do -1, -3, and then let's put 2, 6. But again, remember, we really just need 2. The third one is just for checking purposes, but let's do all of this so everybody gets their point plot. Okay, do you see anything special about this line? What's this line doing that the others were not doing?
We have 0, 0. Staying.
It's going through the origin, right? It doesn't actually cut both axes in different points. It actually cuts both x and y at the same point they meet. Okay, so we call this a line through the origin because notice that there's no little number here without the x. Okay, it's a line through the origin. Let's plot the points. So 0, 0, then 1, 3. Then -1, -3. Okay, and then 2, 6. 2, then 1, 2, 3. Again, I repeat, 2 points is all you need. Okay. All right, and as you can see, indeed, all of these points they do lie on a line. Okay. Call this a line through the origin, and that's how lines through the origin look like. Y equals a number times x. Okay, that's how the equation will look like of a line through the origin. Are you okay with this? All right, let's do this one. Now for this one, if you just randomly pick numbers, most likely you're going to end up with fractions. Okay, so you may need to think a little bit more if you want to be a little bit more clear. Okay, so for example, I'm going to be picking values for x. So then I solve for y. But I want to pick nice values of x. So beforehand, let's actually take a look what it's going to take to solve for y. Okay, so this means that 5y will be 9 minus 2x. Yes, just move the 2x over. So if I want to get nice y's, what does that mean? I should be picking values for x, so that when I put it here, I get a multiple of 5. Because when you solve for y, you need to divide by 5, right? So let's be smart and let's pick numbers here that will give me here in this expression multiples of 5. So we have comfort of points to plot. Okay? So let's see. 0 is not really a good choice, right? Because then you need to do 9 divided by 5. So for example, I could do 2. If I pick 2, what's going to happen? I get 9 minus 4, which is 5. So you can easily solve for 1, right? So what would be another one that we can get easily? For example, if I pick -3 here, right? So what do you get here? It will be 6. What's 9 plus 6? 15.
Oh, sorry.
Right? And then you can easily divide by 5. Okay? So, you just do a little bit of thinking before you actually go ahead and start picking values. You can pick values, but then you have to deal with fractions most likely. Okay? But if you dedicate a little bit of time, you can probably find something nice. Not always, though. Anyways, here we just find 2 points. So let's go with 2 and -3. Okay? When x is equal to 2, does everybody see that y is equal to 1? Yes? Okay. Just plug in and solve for y. And when x is equal to -3, we're going to get 15 on the right-hand side. So what is y? 3. Good. And you see, these are nice points to draw. So I'm going to go with those. So we have 1, 2. And then we have -3, 3. 1, 2, 3. Okay, so you put your 2 points, and then once you have the 2 points, that's all you need. You draw your line. Okay, any questions?
That will be going down, right?
Yeah. This one going down, going from quadrant 2 to quadrant 4.
Gotcha.
Okay?